yesterday. And yesterday we were focusing on velocities and tangent lines. So we know the slope of the tangent line is the same thing as the instantaneous velocity, and it was the limit of the slopes or the average velocities. So we're basically taking 2 points, finding the slope between them, and doing the limit as they got closer and closer to one another. And we had two different versions of that. One of them used the points of a and a plus h, so a number plus a little more. Another one did x and a. We can use either, they are interchangeable. But we also have now, we're going to talk about derivatives. And derivatives are the same thing as an instantaneous velocity or a slope of a tangent line. So it's more of the same thing. So if we have a limit of this form, we see that a lot in science, engineering, chemistry, if you're looking at the rates of a reaction, and economics, when we're talking about marginal costs and marginal revenues. This concept, the derivative, the rates of change, that's why calculus is required for so many different majors in college, because there are so many applications for a derivative. So we are going to learn how to start calculating a derivative. And actually, we've already been doing it. We just didn't know that. A derivative, so we are used to like f of x being a function. For a derivative, you call it f prime of x, just representing a derivative. And it's the same thing. So it's the limit as h approaches 0, f of a plus h minus f of a all over h. So the same thing we were doing yesterday. Or if you did the other notation, you could have the limit as x approaches a, f of x minus f of a over x minus a. So today we're talking about derivatives, but it's the exact same calculation we were doing yesterday with the tangents and the velocities. Okay, so just another name for the same thing. We can use either notation. I'm typically going to use the first one just because in terms of getting things to reduce, it's a little bit easier to cancel a single term off the denominator than two terms. So the math is sometimes a little bit easier with this one. All right, so if I want to find the derivative of this function at the number a. So derivative, we could use either of those notations. I didn't give you an actual number, so that means a is just going to remain a. So the definition of a derivative at a particular point is the limit as h approaches 0, f of a plus h minus f of a all over h. That's our definition that we had on the last slide. So let's do that. So the limit as h approaches 0, f of a plus h says you go to your equation, you replace your x with a plus h. Minus f of a says go to your equation, replace your x with an a. All over h. Can I plug in my h yet? Okay, so what do we do? Start multiplying everything out. So this would give me a squared plus 2ah plus h squared minus 8a minus 8h plus 9. Second parenthesis, I could distribute my negative. So then we should see some things cancel. A squared and a squared drops. What else?
Combine.
Oh, I wrote something down wrong, didn't I? This was supposed to be a minus in the original equation. X squared minus 8x plus 9. So then when you distribute the negative, it will be positive. So then those 8 a's cancel. And the 9's. Okay, when I get to this point, what do you notice? We can take an h out of everything. So that gives us 2a plus h minus 8. And now you can plug in 0 for your h, and what do you get? All right, so this is actually really nice. It's kind of a formula for the derivative. So if I said at the point when x is equal to 1, you could plug a 1 in for your a and you get -6. So the derivative at 1 is -6, or the slope of the tangent line at 1 is -6. Or if I said when x is 10, you can plug that in, you get 12. So then the slope of the tangent line when x is 10 is 12. Okay, so this is just kind of a formula that then we could plug in whatever value for a we wanted and get the actual derivative there. Questions on that problem? So this is what we're practicing today. On the next slide, I just said what we've already stated. The tangent line, slope of the tangent line is the same thing as derivative, so we could be asked to find the equation of the tangent line. This was the equation we just did. So we know from example 4 that we just did, the derivative was 2a minus 8. So if I wanted the equation of the tangent line at this point, the slope, what would I plug in for my a value? 3. Your a is just like your x. And we get -2. So then could we write the equation of a line with a slope of -2 going through this point? Yeah, we were doing that yesterday. So y equals m times x plus b. So our y-intercept is 0. Our equation y equals -2x plus 0, or just y equals -2x. So a is just representing an x value here. Any questions on that one? So we're going to practice more. So a derivative is also slope of a tangent line. It's an instantaneous velocity. It is a rate of change. So it's an instantaneous rate of change at a particular point. So if I look at this example, we're not actually doing much math here. We're just talking about what things mean. A manufacturer produces bolts of a fabric with a fixed width. The cost of producing X yards of this fabric is C equals F of X dollars. Okay, so it's basically telling me my X is the yards of fabric and the Y is my cost, which is measured in dollars. So a derivative is a rate of change. It is a slope. So think about when you find a slope, what do we do? How do we find slope? y2 minus y1 over x2 minus x1. Change in y over change in x. So when you do units on a slope, it's always y per x, because it's y over x. So the units would be dollars per yard. Okay, f prime of x is just a slope, and we know slope is change in y over change in x. So it would be dollars per yard. So what it's telling us it gives a slope, the rate of change, in our production or let me say of our cost, rate of change in cost would make more sense, use the terms in the problem. So it tells us how the cost is changing in terms of yards produced. Okay, so if I said, okay, if I'm going to make 200 yards of fabric, the derivative would tell us if we're making 200 yards, how much would it cost to make another yard? Okay, if I'm making 300, it would tell me how much the derivative would give me, how much it would change my cost to make another yard. So it's the rate of change at that particular point. In practical terms, what does it mean to say that f prime of 1,000 equals 9? So what you're plugging in is your x. So my x is measured in yards. So it's saying when 1,000 yards are produced, a derivative is a slope, so it's a rate of change. So it's not telling me the cost is $9. It's telling me the cost is it increasing or decreasing? Increasing $9 per yard. So I don't know how much it costs me to make 1,000 yards, but I know if I want to make 1,001 yards, my cost will go up by $9. Okay, it's a rate of change. Which do you think would be greater, f prime of 50 or f prime of 500? Okay, so this is kind of a personal opinion, but we also can think about things. In general, when you're making something, okay, so what do we want to make? Pants. Okay, we're going to make pants. We have to buy certain equipment to be able to make the pants, right? So that's like your y-intercept. And then you have a cost per pair of pants for the materials for just that pair. And so if I'm only making one pair of pants, it's really expensive because I bought all this equipment to make the one pair. But if I'm making 100 pairs, it costs me less per pair because I can take my equipment costs and spread it out over 100 pairs, right? So which one do you think would be greater? The rate of change, so that's like the slope, it's how much per pair that we're paying. So would it cost more for 50 or for 500 when we're looking at the cost per pair? So f prime of 50 is going to be greater than f prime of 500. You know, if we're ordering t-shirts, it costs more per shirt the fewer you order, right? Because they have to set up the printing for that one shirt or the 50 shirts. But if you're making 500, they have the printing cost, they can divide it over all 500 shirts and it costs less. Does that make sense? All right, so it might hold true for 5,000, but what's going to happen? If I call CWs and say, okay, I need 5,000 shirts, do you think they can print 5,000 shirts in their facility? Probably not, because what's going to happen? After a certain point, they're going to need more equipment, bigger equipment, more help to come in, those kinds of things. So it reaches a point, for a while, it's going to be cheaper per shirt, but then if we have to upgrade our facility, our costs are going to rise. So it will reach a point where it's no longer cost effective. And that's essentially what we are going to later be finding with derivatives, like that optimal price point. How many shirts can I make for the cheapest amount per shirt before I have to upgrade all my equipment and it starts costing me more? So f prime of 5,000 may be higher? We don't really know. If production becomes inefficient. Okay. At some point, you won't be able to handle an order that big, and so it's going to cost us a lot more to do that. All right. I am going to kind of skip around now. I want to do a couple more problems for today, and then I'm going to give you guys time to work. And then tomorrow we will wrap up the last few examples. So I want to go to example 7. I think we did one similar to this yesterday, example 3. I think there's one similar on the homework perhaps. So we're just going to do a couple similar to like some of the things you might do on your homework, and then we'll stop for today. So if a rock is thrown upward on Mars with a velocity of 10 meters per second, its height after t seconds is given by this equation. Find the velocity after 1 second. Let's do part B first. I'm going to switch my A and B. I think it'll be easier. So part A, I want the velocity after a seconds, essentially. So velocity, same thing as finding a derivative. I'm asking you to find the limit as h approaches 0, f of a plus h minus f of a all over h. So I'm going to my equation, I'm going to replace my t with a plus h. Minus, f of a, so you go to your equation and replace your t with an a. All over h. Now what do? Yeah, algebra. These have a lot of algebra, multiplying things out. So first one, if I distribute my 10, can I FOIL this and distribute 1.86 at the same time? So we would have a squared times 1.86 plus 2ah times negative 1.86 give me negative 0.72ah plus a squared times negative 1.86, so minus 1.86h squared. This one, if I distribute my negative, all right, what now? Yeah, 10a and negative 10a drop. 1.86 a squared and negative 1.86 a squared drop. All right. So now what can I do? Take out an h. So that gives me a 10 minus 3.72a minus 1.86h. All right, and now if you plug in 0 for your h, we get 10 minus 3.72a. So this is a formula for the derivative, or the instantaneous velocity, or the slope of the tangent line. all of those things. It means the same. And so now I can find it at any given point just by plugging in value for A. Is everyone okay with that? Anybody? So if we do the next part, remember I switched A and B. So the original A said find the velocity. Well, velocity is just the slope of the tangent line, or the derivative, after 1 second. So what am I going to do? Plug in 1 for A. And we get 6.28. Velocity would be meters per second. C. When will it hit the surface? If it hits the surface, what's our height? So it's setting the original equation equal to 0. So we could factor out a t. So each part to 0. What would t equal 0 represent? T equals 0 is our starting point. At time 0, it started on the ground. And then we threw it up. So when did it hit the ground again? 5.38 seconds. And then the last part, what's the velocity when it hits the surface? So I know the time. And our velocity is the same thing as the derivative, which we found that formula in part A. So we can plug that in. Why would it be a negative? It's falling. Velocity is like speed with direction. Questions there? Let's try one or two more together for today. Example 8, I have an A, B, and a C. Let's pick 2 to do today. Do you guys have a preference? Let's do A and B today. We'll do C tomorrow. Right, so I'm asking for the derivative. So that's, remember, the definition, it's just the limit. Plus h squared to 0, f of a plus h, minus f of a, all over h. Is everybody okay with my first step? Now we have to do a lot of fancy algebra. It's not hard, it's just tedious. Okay, this 2a plus h cubed. That means you have 3 of those. I'm going to come out to the side and kind of work that out. If you multiply the first 2, we FOIL all the time. A squared plus 2ah plus h squared. So now if I distribute a squared times a is a cubed plus a squared h, and that would be a 2a squared h, so we get 3a squared h. 2ah squared and 1ah squared would be 3ah squared. And then h times h squared is h cubed. If we distribute the 2, plus my a plus h minus 2a cubed minus a. What happens? What do you mean?
Like we cross out 2a squared and negative 2a cubed.
Sorry, this was supposed to be a cubed. Because I took a squared times a. I just wrote it down wrong. Okay, what happens now? We can drop an h out of everything. We get the limit. H approaches 0. 6a squared plus 6ah plus 2h squared plus 1. Now if you plug in 0 for your h's, anything with an h goes away, so you get 6a squared plus 1. Okay, I actually think I'm going to stop there today. I'm going to do the rest tomorrow. So you have that assignment that you're working on. Technically, you could really do the entire thing at this point if you chose to. It's all going to be due on Friday. So tomorrow I think I've got 4 examples to do, and then you'll have work